right, hey y'all, it's Mr. Kyle Myers Mathematics, and let's just jump into it. This is number 55, and we have a really long set of things to work out here. So the first one in this particular little set was 54. There wasn't an answer key for that one, so I was kind of just guessing at what we needed to do for answers because they're a little not too specific. But with this one, what I went ahead and did, and I don't normally do this, but I went ahead and put the answer in here as well, so you can see the answer already. So all the odds that have answers, just like a normal math textbook would. And then, by the way, this is coming from Stax, so it's a free online textbook. At least it is at the time of me making this. Hopefully, it stays free. That's kind of the idea, is that no matter what book your class is using, you have access to this other free book, and you can get some extra practice in at the very least. Hopefully, best case scenario, your class is using the free book, and you didn't have to pay for a textbook, and you can just use this. But let's go ahead and jump in. Newton's method seeks to approximate a solution f of x equals 0 that starts with an initial approximation x sub 0 or x naught, and successively defines a sequence x sub n plus 1 equals x sub n minus f of x sub n over f prime of x sub n. For the given choice of f and x0, write out the formula for x sub n plus 1. If the sequence appears to converge, give an exact formula for the solution x, then identify the limit x accurate to 4 decimal places and the smallest n such that x sub n agrees with x up to 4 decimal places. So again, that is quite the mouthful, but knowing what the book decides is all the answers that you need to have will maybe help with some of the others as well. So let's jump in. The first thing I would probably want to do, and I did this on number 54 as well, is go ahead and just plug in 0 for f of x and just see what the answer should be, what we're working towards. That way we can kind of begin with the end in mind. So f of x is going to be set equal to 0, and that's going to be equal to x minus 1 squared minus 2. Okay, so we're going to solve this. So I'm going to add 2 to both sides. So that's going to be that. Take the square root. This is going to be plus or minus, but since x sub 0 is 2, I'm assuming it's probably going to be the positive version. So I'm just going to leave this as a positive square root of 2, I think. So we're just going to write this as the square root of 2. And then we would add 1 to that. The square root of 2 is about 1.4. So this answer is about 1.4 plus 1, which is 2.4. So x sub 0 equaling 2, that's going to be the closest integer to 2.4. So that's a pretty good place to start, I guess. But that's what we're working towards, is about 2.4. If I wanted to do some more decimal places, I could. And in fact, let me see here. Do I have decimals? I always have decimals pulled up. Here we go. So the square root of 2 plus 1, if we want to write this accurate to a few more decimal places here. 2.4142136. I'm just going to do a bunch because later on we're going to need to get an n value that makes our x equal to this answer accurate to at least 4, could be more than 4 decimal places. So let me move this over here. There we go. Okay. So next thing, so we're beginning with the end in mind. That's actually not part of the answer, but I like to start with that so we know what we're shooting for. The next thing I would probably do is go ahead and do what they have as the first answer here and go ahead and plug in f of x. So f of x sub n would just mean that everywhere there's an x, you just put an x sub n. So that's not really that big of a deal, but we do want to go ahead and find the derivative. So I'm going to rewrite f of x. And this is quantity squared minus 2. So you could take the derivative one of two ways. You could either distribute the square and then take the derivative, but I'll probably actually just do the chain rule on this. There's not really a chain rule at all, but I guess you would call it a chain rule. because the inside derivative would be 1. It's not much of a chain rule, I guess I should say. So this would be, bring the 2 out front, power minus 1, and then you would times by the derivative of the inside, which is 1. And then the derivative of any constant goes to 0. So this would be, let's go ahead and put it in terms of x sub n. This would just be 2 x sub n minus 2. And if we were to distribute that square, it would actually be the same thing, because if I distribute that square, and by distribute, I don't mean like times x, take x squared and then 1 squared. I mean factor it, or not factor, sorry, FOIL it, x minus 1 times x minus 1, which would be x squared minus 2x plus 1. Plus 1 minus 2 would make negative 1, but it doesn't really matter because you're going to take the derivative of that, and when it would go to 0 anyways. But the x squared minus 2x, the x squared would become 2x, and then minus 2x would become minus 2. So either way, you should get the same answer, no matter which way you took the derivative. Okay, so then we'll go ahead and plug that in. As I'm writing this over here, it's actually going to look a lot like what's right above it, but that's totally okay. So it's this, and then as the formula goes, you put a minus sign, and then you have f of x sub n on the top. So I'm just going to put x sub n minus 1 squared minus 2 over. And then that would be, actually, you know what? I'll probably leave that factored because I might be able to cancel something. Maybe. We'll see. Because if I split that up, I'd be able to, I don't know. The answer didn't split it up. They actually kept it factored as well, but they didn't try to clean it up a little bit. You could probably try to clean it up and look for patterns that way. And also cleaning it up might help to simplify it a little bit. That's what I did on 54 is I cleaned it up. It looks like they didn't really clean it up at all. They kind of left it just as is. So it just depends on how picky your professor is. I think I'll probably leave it just because if I distribute that, and then that would be plus 1 minus 2 would be a minus 1, I wouldn't be able to refactor that afterwards. So I wouldn't be able to get it completely factored and then have it cancel with something down here. I could split up the fraction, but it's not super, super helpful. It might be helpful to simplify it a little bit to make it easier when you're going to go and plug in stuff. But the other thing you could do is if you're allowed to use a graphing calculator, just plug it into that. Or if you can use Desmos, if you're working out your homework online, just use Desmos and type all of this stuff in as a function. So this would be like y, and then this would be x, and you could do it that way. That way you can get your values pretty easily. So that's probably what I'll actually end up doing is I'll probably just type it into Desmos, like all of this, you know. So that's pretty much the answer to writing out the formula, and I'm using white slash out, let's use red. Write out the formula for x sub n. So that's the first part. If the sequence appears to converge, it should converge because Newton's method is approximating something. So it should be converging onto the square root of 2 plus 1, which is approximately 2.414. So it should be doing that. You can find out if it's doing that with a table. So I'm actually going to go ahead and do that now. Let's put a little divider here. So n and x sub n. Tables are almost always a good idea. I do a t-chart for almost everything, and I recommend you do it as well. We're going to start with an n value of 0. So if n is 0, then x sub 0, they say, is 2. That's all this initial stuff right here, right? So I'm just pulling that from the initial. If n is 1, then I'm plugging in 0 for n, which seems a little weird because I'm actually trying to find the n value of 1, but I'm plugging in 0 for n. That might seem a little counterintuitive, but it's just the way that recursive formulas tend to work. If I plug in 0, I would be finding out what x sub 0 plus 1 is, right? So I'm finding x sub 1. This would be x sub 0 minus, and then all of this, right? So x sub 0 minus 1 squared minus 2. I'm going to write all of this out probably just the first time and then not all the times after that, just because I'm going to run out of space here in a little bit. But then also, I would probably just recommend typing it into Desmos. If you're not allowed to use a graphing calculator, you can type all of this into a scientific calculator. It's just that you'd have to type it in again and again and again for different values. So it's a little more tedious if you're not using a graphing calculator. It is what it is. We know x sub 0 is 2, so we'd be plugging in 2. It'd be 2 minus, and then 2 minus 1 is 1, 1 squared is 1, 1 minus 2 is negative 1, over, and then actually I can go ahead and distribute that negative, so just make that plus. And then over, that'd be 2, 2 minus 1 is 1, 1 times 2 is 2, so over 2. So you can do this by hand, but I probably wouldn't recommend it. 2 plus a half is 2.5, or you could say 2.5. So it's equal to 2.5. So when when n is 1, x sub 1 is 2.5. And I'll probably leave it in decimal form just because we are looking for a decimal approximation. We're looking for how accurate it is as we keep going. So I'm going to go ahead and type this into Desmos now. That's why I'm looking over here. So I'm going to just type in f of x. If you're using a graphing calculator, you would do it's already preset y sub 1. But on Desmos, I would call it f of x. And the reason why is so that I could plug in an x value. So f of x is equal to x minus. So if you're using Desmos, I would recommend doing this along with me. If not, you can just kind of scrub ahead a little bit. But if you're using Desmos, you would type in f of x equals x minus, and then we'll actually need we'll need a bracket to put all of this stuff in the numerator together. A bracket, open parentheses, x minus 1, close parentheses, shift 6 to square, and then hit the 2 afterwards to square it. Right arrow, minus 2, close bracket, slash key on the keyboard, which is also where the question mark button is. And then that'll take you down into the denominator, and that's going to be over 2 parentheses x minus 1. Okie dokie. And that's graphing a line. So that's interesting. At least it looks like a line. Ooh. Oh, that's because I was way zoomed out. I was like super zoomed out. Yeah, it looks like a diagonal. Okay, so it's got a diagonal asymptote and it has a vertical asymptote. Interesting. So if it has a diagonal asymptote, then as x gets bigger, oh, but it's recursive. Yeah, so I'm treating it like an explicit formula, but this is not an explicit formula, it's a recursive formula. So I need to be careful not to treat it like it is an explicit formula. Or at least it's recursive-ish. It might not be completely correct to call it recursive, but it's basically recursive. Okay, so we already found out that f of 1 was 2.5, and let's see, we would need, oh, dang it. You know what? We would have to plug in a very specific x value. And then, yeah, because the x sub n would have to be, we would be plugging in 2.5. So we want f of 2.5 because we'd be plugging in 2.5 to get the next one. So we want f of 2.5. And I get, so when I plug in f of 2.5, I'm plugging in 2.5 for x, which means I'm plugging in n equals 1. So n equals 1, so I'm finding out what x sub 1 plus 1 is, x sub 2, equal to x sub 1 minus x sub 1 minus 1 squared minus 2 over 2 times x sub 1 minus 1. So I'm plugging in 2.5 because that's what x sub 1 would equal. So I'm finding out f of 2.5, which is 2.416 repeating. 2.416 repeating. Now we're already pretty close. So we're here now, and we're here. We're already to 2 decimal places so far. So with n equal to 1, we're still no decimal places yet. But then by the time we get to n equals 2, we've got 2 decimal places of accuracy here. Next is 3. So what we would do is we would actually plug in 2.416 repeating into f. And what I'll actually probably do is on Desmos, you can do this 2.41, and then I'm going to type in a bunch of sixes. When you first type in a couple sixes, it'll have that little fraction box over a box icon on the left-hand side of Desmos. But then as you type in more sixes, it goes away because it's kind of like a really big, it would be a really big fraction at that point. But as you put more and more sixes, that fraction box will come back on Desmos. And then you can actually take that, it'll know that you're trying to make that value a repeating decimal. And then you can hit that box, you can click it, and it'll tell you what that is as a fraction. So it's 29 twelfths would be the exact amount. 2.416 repeating is 29 twelfths. There is a way to take repeating decimals and turn them into fractions by hand, but it's really long. Unless it's like a point, 2, 3, 4, 5 repeating, then it's a long process to do it by hand. So I probably, if you can use technology, I would probably do that. It's a fun little thing to learn, but I actually never really learned how to take a repeating decimal and turning it into a fraction until I was like in college. I guess either I wasn't paying attention that day in class or whatever, but because apparently you learn it at some point in like middle school or high school or whatever, depending on who your teacher is. Anyways, rabbit trail. So 29 twelfths, I'm going to plug in uh, because when n is 2, x sub n is 2.416 repeating, I want to write that as a fraction so I get the most amount of accuracy. So I want f of 29 twelfths. 29 twelfths is 2.416 repeating as a fraction. So now I'm going to find out what f of that is, and it is 2.414 2 1 5 6 8 6 2 7. So I'm gonna round up to 7, just because I'm already past the point where I get to match the actual answer here. So the actual answer would be this. Now I'm 2 4 2 1, and then the next digit I have is a 5. So I am now to 1 2 3 4. I am now to 5 decimal places of accuracy with n equals 3. So I've got a few more, and that's sufficient. So we can actually stop there. And now I'm a little confused by their answer here because they're saying n equals 5 to get an answer that agrees with x up to 4 decimal places. I think I would disagree with that answer. They're saying n equals 5, but n equals 3 is accurate to 5 decimal places, which is, even more than 4. So I don't know if I would agree with their answer. Now, they do have the x value here written out, 2.4142. So they have it to 4 decimal places here. I went a little further than that just because they have this right here. This is the actual answer. So we have that as well. And it's this. They say n equal. I don't agree with that because you can see clearly that n equals 3 gives us 5 decimal places of accuracy. N equals 5 would be a lot of decimal places of accuracy. A lot more. I don't know exactly how much more. And I don't know that we would need to write the explicit formula. I don't see them in the answer key here, writing the explicit formula. I mentioned this on number 54. So I know I keep mentioning 54. If you don't need 54, I'm sorry that I keep mentioning it. But I did talk about the explicit formula for 54. It looks like the answer key doesn't include it. So hopefully your professor doesn't want you to write the explicit formula. If they do want you to write the explicit formula, let me know in the comments down below. But I'll start praying for you because it would be crazy. It would be a little crazy to find the explicit formula for this. So just letting you know. So go ahead and we'll probably lock this down at this point and stop here because we've basically got everything that the answer key has. So again, if you need a different set of answers than what is in the answer key, if your professor needs you to write out more, just let me know what they're looking for. I'd be happy to kind of do a follow-up video on it to help you out. But I just need some feedback on that. So let me know. And I'll catch you guys in the next video. Don't forget to check out the 5 math mistakes everyone makes and how to avoid them. That is on my website, Irish Mathematics. That link is down in the description below. You can check me out and see what that is. It's a free PDF, but I have other stuff on there too. If you want to get just know what I am, what I do, math teacher, tutor, and content creator, and all the things that are on there. So check it out, and I'll catch you guys in the next video. Blessings, y'all.